This is second part of video lecture for week 7. Here we continue the application of differentiation. Here we study indeterminate forms and L'Hopital's rule. In fact, the L'Hopital's rule is used to find the limit using the differentiation. Let's see some 3 examples here. Limit of x square minus 1 divided by x minus 1, x minus 1, x square minus 1, x minus 1, x square minus 2x plus 1. So if you substitute x is equal to 1 in all these 3, you get 0 by 0. But we can factorize this. So we do this, and then x minus 1 cancels. We get this. Now I substitute x is equal to 1, I get the limit. So initially it was 0 by 0. Then we do the factorization and cancellation. Then we got the answer. Similarly, in this case also, we factorize the denominator. X minus 1 cancels. We get the limit 1 by 2. Initially again it was 0 by 0. In the third case, again initially when I put x is equal to 1, we get 0 by 0. Then we factorize this. X minus 1 into x minus 1 cancels. We get this. And further it cannot be cancelled. So I put x is equal to 1. Then I get 1 by 0. That is infinity. That means the limit does not exist. You see that all these functions, initially the limit was 0 by 0. But after factorization and cancellation, we got the limit. Another example. Let's take these 3 examples. You put x is equal to infinity in these 3 examples, you get infinity by infinity. But you know that whenever you are asked to find the limit of any function as x tending to infinity, you need to divide the numerator and denominator by the highest power of the denominator. So I will divide the numerator by 1 upon x3, 1 upon x3, this. Then I get this as x tending to infinity, 1 by x tending to 0. So this is 0, this is 0, this is 0. So 0 by 1 plus 0, that is 0. So look at it. Initially it is infinity by infinity. I do the sum operation, that is divide the numerator and denominator by the highest power of the denominator. I get the answer. That limit exists. Similarly here also, the highest power is x square. So I will divide 1 by x square. Here highest power was x cubed. So I divide. So now it is x square. I divide it. Then I put as x tending to infinity this 0, but there is x here. So infinity by 1 is infinity. So limit doesn't exist. In this again we have infinity by infinity. The highest power is x square. So I divide this and this by x square. Then I get the limit exists. So look at it. In all these 6 examples, what we have done here is we initially got 0 by 0 or infinity by infinity by some algebraic what you call manipulation. We get the limit, and sometime it exists, sometime it doesn't exist. So what the L'Hopital rule says that suppose if you have a limit of a rational function, and when I put x is equal to c in the numerator and denominator, if we get 0 by 0 or infinity by infinity, then what you have to do here is you find the derivative of numerator and denominator separately and continue. Let's say an example here. Limit of 1 minus cos x by sin x as x tending to 0. Put x is equal to 0. Cos 0 is 1. 1 minus 1 0, sin 0 is 0, so therefore you get 0 by 0. What I will do, I will differentiate the numerator and denominator separately, not together. So derivative of 1 minus cos x, derivative of sin x. So here I applied this formula, L'Hopital's rule here. Derivative of 1 is 0, derivative of cos x is minus sin x, so minus into minus plus, derivative of sin x is cos x. Now again I put x is equal to 0. Sin 0 is 0, cos 0 is 1, 0 by 1 is 0. You see, the L'Hopital's rule helped me to find the limit of this, but initially it was 0 by 0, but when I apply this formula, I got the limit. Similarly, this example, limit of e raised to x by x as x tending to infinity. I put x is equal to infinity. E raised to infinity is infinity, this infinity, so therefore this gives you infinity by infinity. So I will apply the L'Hopital's rule. So remember, you need to use L'Hopital's rule only when you get 0 by 0 or infinity by infinity initially. So I separately differentiate this separately. Don't mix up. If you want to call combinedly, you need to use the quotient rule. But L'Hopital rule says you need to find the derivative of numerator and denominator separately. So derivative of e raised to x and derivative of x separately. E raised to x is same, differentiation of x is 1. Now you put x is equal to infinity. So infinity by 1 is infinity. The limit does not exist. Another example, limit of x square e raised to x. I put x is equal to infinity, you get infinity by infinity. So I differentiate. So I get this 2x by this. So now you put x is equal to infinity. Again you get infinity by infinity. So again I will use the L'Hopital's rule. In the earlier two example, I used the L'Hopital's rule only once. But I am using here another time because in the first I got infinity by infinity, I used the L'Hopital rule. After applying the L'Hopital's rule once, again I get infinity by infinity. Therefore, again I will use. See that every time you get 0 by 0 or infinity by infinity, you continue using the L'Hopital's rule. If you don't get 0 by 0 or infinity by infinity, stop using the L'Hopital's rule. So since I get again, so therefore I will differentiate this again. So differentiation of 2x, differentiation of ex. I get this. Now again I put x is equal to infinity. 2 divided by infinity. That is 0. I got the answer. So look at it. You are using the L'Hopital's rule only when you get 0 by 0, infinity by infinity. Let's say this example. Finding the limit of x square e raised to x minus 1 as x tending to 0. So I put x is equal to 0, 0 by 0. So therefore I use the L'Hopital's rule, differentiation of x square 2x, differentiation of this is this. Again I will use the L'Hopital's rule. So differentiation of 2x is 2, differentiation of this is same. Now I put x is equal to 0, 2 by 1 is equal to 2. This is wrong. Why it is wrong? Because when I used the L'Hopital's rule first time, it was 0 by 0, so this is right. But when I use second time, I put x is equal to 0, but you get here 0 by 1, e raised to 0 is 1. So you cannot use L'Hopital's rule again, because when I put x is equal to 0 here, I am getting 0 by 1, which is not 0 by 0, which is not infinity by infinity. Therefore, from here to here, the step is wrong. So therefore, this you cannot use. So here, that's why the correct thing is, see, I get 0 by 0, I use once time the L'Hopital's rule, then when I put x is equal to 0 after using one time the L'Hopital's rule, I get 0 by 1, 0 is the answer. So this step is wrong. because this doesn't give me 0 by 0 or infinity by infinity. Sometimes you need to do the simplification in finding the limit. For example, limit of ln x by cosecant x as extending to 0 plus 0 plus means greater than 0. So I substitute x is equal to 0, ln 0 is infinity, cosecant 0 is infinity. So we get infinity by infinity. Then we find the apply the L'Hopital's rule. Then we find the derivative of ln x cosecant separately. Then we have this. Then when again I put x is equal to 0, again I get this. So this process continues. To break up this, what I will do here is I will rewrite this expression. That is, I simplify this expression. What I write, this cosecant I can write 1 upon sine. And then this cotangent we can write as 1 upon cotangent we can write as tangent. So therefore 1 upon x minus cosecant cot x I can write minus sin x by x because 1 upon sin x means this sin x is up. 1 upon cotangent is tan x. Now what happens? Now you put x is equal to 0. So limit of this sin x by x is 1. Because of this minus 1 it is minus 1. So limit of tan x is 0. So minus 1 into 0 we got 0. So here if I don't use this what you call simplification, this infinity by infinity goes on continuing. So therefore I need to do some simplification sometime to get the limit. Of course, these are the 0 by 0 and infinity by infinity are not the two indeterminate form. There are 5 additional indeterminate forms are there in mathematics. They are minus infinity, 0 into infinity, 0 raised to 0, 1 raised to infinity, infinity raised to 0. What do you mean by indeterminate form? Where there is no value, even if you, these are all just an expressions, there are no values for this, so which you cannot calculate by calculator also. So therefore they are called indeterminate, that means the values of which you cannot calculate. So there are 7 indeterminate forms in mathematics: 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 0 raised to 0, 1 raised to infinity, infinity raised to 0. So in the next class, we will continue with the indeterminate forms of how we are finding these other 5 indeterminate limit of these 5 indeterminate forms. Thank you.